Hi, children. So last lesson, or the first half of this lesson, we found this fascinating formula, V equals D over T. Good job, us. Yay. Um, Most people probably knew it already, but it's good to have it written out. And remember, it's total. We don't care about how fast you were going every single second. Just take the total traveled and the total time, and that's how you solve it. But we got to figure out Daisy's point from before. So there's two ways to answer the problem. If I drive to school 30 miles an hour, how fast do I drive back to average 60 miles an hour? One answer is infinite speed. You have to go infinitely fast. If you have to teleport back, if you teleport back, then you went the same, you took the same time total and double the distance because you went there and back. So then you could double the speed to 60 miles an hour on average. But Daisy's point was said, no, if you go to school and back, you actually went 0 miles an hour because you started at home and end at home. You didn't go anywhere, so 0 miles an hour. We're going to look at both those things because actually that's a very valid point in physics for a lot of reasons. So let's look at an example. The D in this formula can actually stand for two different things: distance and displacement. And they're not the same thing. Okay, so how do we figure it out? Think about the tortoise and the hare. The tortoise and the hare were in a race. They started in the same place. They ended in the same place. But the tortoise went straight from start to end. The hare went to go pick some strawberries, then went to go take a nap under a tree, then went to go swimming, then went to see its friend, and finally went to the end. You guys know the tortoise won. Spoilers. You guys know they both started in the same place and ended the same place. They have the same displacement. Displacement is how you get from your start to your end. But distance you add up every single step the animal makes. The hare went to all these different places, and we count all those little distances. It's the total, how do I say it? Total motion. That's not really the best definition. I'll get a better one real soon. But in this example, the tortoise and hare had the same displacement, but the hare traveled a much greater distance. So that's one example. Here's another example. Let's say I live here and my friend lives here, and there's a nice restaurant right here. Let's say this is 2 kilometers, 2 kilometers. Okay, this is a very silly example. Let's say my friend wakes up at their house, walks to the restaurant, gets some food, and walks back. I'll think, what did my friend do? In physics, we call position x. It doesn't really come up except in this example that I'm talking about right now. X is position. Okay, so if I call my friend and say, hey, what'd you do today? They might say, oh, I got out of my house, went to the restaurant. Great. Good story. Wow, fascinating. I would say, oh, I see. So you were at an initial position, I'll use subscript 0 or x naught again for the initial position. You were starting at 2 kilometers and you went to 4 kilometers. So you traveled 2 kilometers. My friend would probably say, no, I started in my house. My house is at 0 kilometers. And I went to that restaurant. The restaurant is at 2 kilometers. We disagree on the position of my house and their house and the restaurant. I would say my house is 0, your house is 2 kilometers, the restaurant's 4 kilometers. But they would probably say, no, my house is 0, the restaurant's 2 kilometers, your house is negative 2 kilometers, or something weird like that. But it doesn't matter. In physics, we don't care about position. We only care about when we say displacement, start and end. If you want a mathematical formula, displacement is your position minus your initial position. So for me, I'll say the position, well, if you're at the restaurant, you're 4 kilometers away, but you started 2 kilometers away, so your displacement was 2 kilometers to the right or forward. And my friend would say, no, my initial position was 0 kilometers. I went to the restaurant at 2 kilometers, so my displacement is, 2 kilometers. We disagree on our position, but we agree on our on my friend's displacement. So we'll stick with that for now. Now, how are displacement and distance different? We need to think of something like a definition, a mathematical definition. Any ideas how we can mathematically, or with a very strict rule, say this is distance, this is displacement? Tell me if you have an idea. I'll give you an example. The example from last lesson: my house and the school are 10 miles away, 10 miles apart. I'll give you guys a big hint. Let's say it's 10 miles east. How can we clearly differentiate distance and displacement in words? Tell me right now. Okay. If I go 10 miles east and then 10 miles west, what's my distance? What's my displacement? The distance is 20 miles. The displacement is 0 miles. It was 10 miles east, 10 miles west. So we had the same 2 paths, same 2 trips in both cases. But if you add 10 miles east plus 10 miles west in terms of displacement, you'll get 0 miles. 0 miles east, 0 miles west, doesn't matter. 0 miles north, 0 miles south. If it's 0 miles, its direction doesn't matter. But for displacement, from start to end, I start and end in the same place. There's 0 displacement. In distance, it's 10 miles, 10 miles. You ignore direction. That's the difference. If you're finding the distance I traveled, it's 10 miles plus 10 miles. If you're finding my displacement, 10 miles east plus 10 miles west, it's kind of like 10 miles east plus negative 10 miles east. 0 miles east, that makes sense. Displacement involves direction. Distance does not. There's no direction involved. That's the formal definition. That's how you formally describe the difference. Distance, direction. Distance has no direction. Displacement does have direction. Distance is called a scalar. Displacement is called a vector. I'm going to write that down. It's super important over here. Scalars and vectors. We know that distance is a scalar. And we know that displacement is a vector. Vectors have direction, like a direction in space. A direction you actually like point your hand, like, oh, that way, that way, that way, north, south, east, west. Scalars don't have that. They only have the number part. They have the units too, but they have only the quantity, the amounts. So try yourself. What do you guys think? Let's say categorize these things. Categorize mass, categorize velocity, categorize temperature, and we haven't learned it yet, but it's really important. Force. Do you guys think force is a scalar or a vector? Okay. Um, Mass is a scalar. Your mass doesn't have direction. You can't say, oh, I lost 5 kilograms. Which way? Left? No, it doesn't make sense. Velocity, we'll see, is a vector. Force is a vector. A very rough definition of force is a push or a pull. You push or pull something in a direction. And temperature. Temperature is a scalar. You might say the temperature went up, the temperature went down. That's not really up and down. Temperature doesn't go anywhere. It's a scalar. Another really important one is time. Time is a scalar. We might say, oh, forward in time, back in time. That's not really a direction you can actually like point. There's no arrow of time flying through space. It's a scalar in our level of physics. Okay, so the rough definition is that scalars have something like 5 meters north. 5 meters north is a vector. 5 meters is a scalar. They're not always the same 5 meters though. In this example, the distance scalar was 20 meters. The displacement vector was 0 meters. They don't always have the same number, but in this case they do. So I can travel a distance of 5 meters, or I can have a displacement of 5 meters north. 5 meters is called the magnitude. We used the term order of magnitude earlier. Magnitude means size, so the number and the units are the magnitude. Scalars and vectors both have magnitude, but only vectors have direction. Technically, you need direction. If you see a test problem that says, what's the displacement of this lamb? And the answer is 10 meters east, and you write 10 meters, that's not correct. But that's very rare. Most questions on tests and AP tests and practice problems will say, tell me the magnitude of my velocity or the magnitude of the force. And if that's true, you can ignore the direction and you'll get the right answer. So that's pretty good. What else did I feel like talking about today? Some physics stuff, I guess. But that's speed and velocity. No, that's not. Speed and velocity. So distance is scalar, displacement is vector. If you understand that, then it's really easy. Speed is distance over time, and velocity is displacement over time. So velocity is a vector, speed is a scalar. The letters help you remember. Speed is distance over time, velocity is displacement over time. So back to Sage's idea in the beginning. Let's say I drive 10 miles east and then 10 miles west. Let's say the whole trip takes me 1 hour, easy. 10 miles east, 10 miles west in 1 hour. What was my speed? What was my velocity? Tell me right now. Good job. Thanks for telling me. We did a great job this lesson. I definitely didn't mess up and forget to record. I definitely didn't mess up and have to fix it 100 times. We're all physics scholars. We're going to move on to some great stuff.